F's and T's. Take a look, compare what you got with what I got. While you're doing that, I will also tell you that I have activated our Microsoft Teams team for this course, and I will be posting the link to our team for the playlist on YouTube that I have made that will have all the class video on it in order by date, so that you can, if you miss a day, you can go back and take a look and watch a video, or if you want to review any lessons, you can do that too. Yeah, questions about anything you see on the screen there? Ooh, yes, we haven't got to 5 yet, but I will. Maybe you got it right. Can I slide this thing up? Does anyone have questions about any of the ones that are on the screen? 1F. Okay. So if I'm solving this thing for t, I want to make sure, zoom in on 1F. I want to make sure that I get rid of any terms that are separate from the t. So this is positive and it's being added to the ht, so I'm subtracting this guy over. So I'm going to take away the r, I'm going to take away the r, I'm going to get w minus r equals ht. And now, because I'm multiplying the h and the t, I want to isolate for t, so I'm just going to divide by h and divide this whole side by h. So t equals w minus r over h. Does that kind of make sense?
Yeah.
If you divided first, then you'd have to make sure you also divided the r by the h, and then subtract that over after.
I think mine works too. I had the double e divided by r plus h.
You shouldn't have an r in the denominator because you're not multiplying by the r up top. It's not r plus h all times t. Unless you want to show me what you've written. Maybe I'm misunderstanding. Oh, you're not, if it was like this, that would be correct.
Okay.
But it's not, because it's not like that, it's just h times t. Okay, zoom back out. Okay, does anything else from this chunk up top here that anyone wants me to go over? I talked about a couple of them, I think, already yesterday. We looked at B, and then I said I wasn't going to do F, but that F was going to be similar. This is an answer for F. It is not the only answer for F, but it is an answer.
It's so annoying how they can have multiple answers.
Yeah, it's because so much, like you can deal with the algebra in different orders and still it's ultimately mathematically correct. So what I did was what's written in green here. I multiplied up the 1 plus AT and I divided down the D kind of in one step. So I got 1 plus AT, and then that's going to equal big D over little d. And then I subtracted that one, and then I divided the whole thing by t. That is not the only acceptable answer. Sorry, divide the whole thing by a, rather. This is also a totally acceptable answer. Big D minus little d all over AD. It's a way cleaner version of this, but it is functionally the same. I can show you how to get from this to this if you'd like. Don't worry, after this first unit, which is a smaller unit, you're never going to see things this gross again in this course. Okay, we wanted 5. Well, let's take a look at 5. Using the density formula to find the mass of this, so I'm going to actually have to grab a separate sheet of paper because I don't have space there. So question 5, the density formula is this. Rho equals m over v. I'll zoom in so it's easier to see. And then in the first part of 5, it says use the density formula to find the mass of, I have a 55.2 cubic centimeter aluminum chunk. And we're told that the aluminum has that says DAL, that's the density of aluminum, is 2.7 grams per cubic centimeter. So I mean, there's two ways you can approach this. You can isolate this formula first, or you can plug in the numbers first and then move them around. If we were finding the mass, I would just multiply both sides by the volume here. Cancel out the volume, and you're going to get the mass is equal to the volume times the density. And you see, all you're doing is you're multiplying these two values together. If you do that, you should get that aluminum has a mass of 149.04, and the mercury one should be 938.22 grams. Does that make sense, or do you want me to do something different and slower? Yes. Yep. Like at this stage or at this stage? Okay, sure. So if you're just going to go straight from this formula, rho equals m over v. For the aluminum one, it's going to be 2.7 equals m over 55.2. And because I'm dividing by 55.2, I'm going to multiply both sides by 55.2. And those cancel. So then this is what you're going to ram through your calculator. And it's the same for mercury. They give you the volume of mercury, and they give you the mass of the mercury. Sorry, the density of the mercury and the volume of the mercury. And away you go. Here day. You betcha. Are we cool with 5?
Yeah.
Okay. So then question 6 is this guy here. The average cost A of a production of N stereos is given by the formula, that one. So, I'll write out the formula and we'll take a look at it. Now the formula is A equals 15,000 plus 60N all over N. And we're told that in the question, how many stereo sets would have to be produced for the average cost to be 80? So A represents average cost, so this is the formula we're trying to solve. 80 equals 15,000 plus 60N all over N. So this is the upper end of what you would have been given in Math 10 and been told to solve. We want to gather all of our n's together, and to do that we have to get this one out of the denominator. So we're going to multiply n on both sides. Here my n's will cancel. And what we're going to get is 80n equals 15,000 plus 60n. And now this is a lot more doable. To gather my n's, I'm going to bring all of the terms with n onto the, I'm going to go bring them onto the left-hand side. So I'm going to take away 60n, I'm going to take away 60n. We're going to get 20n equals 15,000, which, to make my life a little bit easier, I'm going to say that 2n equals 1,500. Just divide both sides by 10. And then I divide by 2, and I'm going to get that the number of stereos required to do this is 750. Again, you get your calculator to do all that. You are not obligated to do that in your head. Here, does that make sense? Okay. Okay, are there any other questions about 6? Are we cool with how 6 was done? Okay. Then 7, the temperature below the Earth's surface. If you had a Math 9 class with me, we basically did this my pre-dib class did this exact same question. T equals 10D plus 20. We're told that is the formula of the Earth's surface. And if we're, below the Earth's surface. So this represents temp. This represents depth. And the question, there's 2 parts to it. First one says the deepest hole in the Earth is a test drilling hole in Russia. At the bottom of the hole, the temperature is expected to reach 170 degrees Celsius. The only reason that that's the bottom of the hole is because the drill bits didn't survive to go any deeper. So the Russians, and when the Russian scientists give up on something, that's a big deal, because Russians don't give up on crap like that. But this is where we're at. So we know that at some depth, the temperature is 170 degrees Celsius. We want to figure out what D is. So I'm going to substitute this in for the temperature. We're going to get 170 equals 10D plus 20. And now this thing's the thing we're going to solve. Where D is, I think it says D is the depth in kilometers. So I'm going to subtract 20 over. I'm going to get 150 equals 10D. And then division by 10 is nice and easy. It just knocks off a 0. So the depth there is going to be 15. So 15K. They didn't get very far, all things considered. I mean, straight down, I guess that's a pretty decent distance. But yeah, they start melting drill bits, so they gave up. 170 degrees Celsius is pretty warm.
What's that?
Do you bake at home? So you'd be familiar with that if it was in Fahrenheit? 170 C in... it's just under 350 degrees Fahrenheit. You could bake cookies at 15 kilometers underneath the surface. That's a big deal. Like that's really warm. And then part B is the other way. What is the depth? Oh no, that's the same. It's the same way. Estimate the depth of a mine in which the temperature is 420 degrees Celsius. So the only difference there is this becomes 420. You're still solving for D. The math is exactly the same. You're going to get that depth is 40K-ish, which again is still not through the Earth's crust. And 420 degrees Celsius is almost 800 degrees Fahrenheit, which is it's pretty warm. Still not as hot as the thermite reaction I did with my grade 10s last year.
So you did grade 10?
My science 10s, we did thermite. Vine, you were in that class, right?
You did grade 3 thermite, or was I not?
Were you heavy semester 1 or semester 2?
That's semester 2.
I did it. Maybe you were on for it. I did this.
Rad might have never let us do something like that.
Oh, Radman brought his class down for it.
Oh,
Yeah, this is my hunk of thermite. When we get, I can do it again with you guys. Sure, let's do it again. It was good. I had fun. Let's make more. Let's do a bigger one this time. Okay, so that was the homework I gave you. Are there any other questions about anything any of you would like to go over? These are some of the nastier ones that I would ever give you. I have a philosophy, perhaps I should, maybe these 8 people who've dropped Physics 11 over the last week, maybe I should have told them this. Your tests are never going to be as ugly as the work I assign in class. My goal is that if you can do the work in class, the test I give you will be fine. I will always assign work that you do with me and each other that is beyond what I would give you on a test. And so some of these really gross ones, I'm not necessarily going to, that's not necessarily the kind of stuff that's going to show up on a test. Okay, so today I'd like to get through a couple things today. I know I said that yesterday too and we didn't. Take a look, flip the page. We're going to review some trig. It doesn't matter what Math 10 class you took. Y'all should have done some trig.
Ours didn't. Half of ours didn't.
Seriously?
We only taught it to half of our class.
In grade 10. Oh, right, because of the end at the end.
Yeah.
But you were part of the half the class that
No,
got
I
it.
was not.
You gave up? Okay, trig's easy. Let's do some trig. Right, I remember that 10 class. That 10 class was wild.
Yeah.
Here we go. Trigonometry. So, there's 2 pieces to trig that are useful to remember. The first is the Pythagorean theorem, which all y'all did, because that happens back in middle school. The Pythagorean theorem says this. We're going to label some sides of the triangle. The Pythagorean theorem is a relationship between these 3 sides. It's only true for right-angled triangles. And in Physics 11, we are only going to use right-angled triangles. And it works like this. It says that a squared plus b squared equals c squared. And it relates 3 of the sides. The only side labeling that we actually care about is which one in that triangle. The hypotenuse, and it's which of these letters gets the hypotenuse? Which of these letters? C. So this is the only one that we care about. The hypotenuse is always labeled C in the Pythagorean theorem, and this side is A and this side is B, or maybe this side is B and this side is A. It doesn't actually matter what the other two sides are.
How do you call them though?
What do you mean?
How do you call A and B? Like, they have names too, right? I just don't know their names.
Oh, they're called legs. You have the hypotenuse and you have two legs.
There's also offset and adjacent if you're going.
But that's only, that depends, that is always relative to a particular angle, which we're going to talk about right here. Okay, so that's the Pythagorean theorem. Regardless of whether or not you had trig taught to you in Math 10, this I know you've seen before. You do it in grade 8. You do it again in grade 9. You're supposed to do it again in grade 9. That's the Pythagorean theorem. It generalizes, so for those of you who are in, I think it's both Form 11 and Pre-Calc 11, you do this. This thing is going to eventually generalize to something called the cosine law. The cosine law looks like this. C squared equals A squared plus B squared minus 2AB cos C, where this angle, so if you recall, if you've seen this before, angles get labeled the same letter, but the capitalized version of whatever side they're across from. So if this is angle big C, that means it's across from side little c. So in this triangle, this is what we would label big C. It just so happens that the cosine of 90 degrees is 0. And so when you have a right angle triangle, this is true because you have negative 2ab times 0. So this whole piece here ends up being 0 in a right triangle. Again, you're not going to need this in Physics 11. You're going to learn it at some point in a Math 11 course. And I don't actually think it matters what grade 11 course you're going to take. You'll see it there. It's cosine law. It's a great little tool. But you will definitely want this handy for Physics 12 whenever you should take that course.
Are you teaching Physics 12 next year?
Usually Morrison and I alternate back and forth. So usually I'll teach 11 one year, he'll teach 12 and back and forth. I really like teaching 11 though. So I might keep I don't know. I would like to teach 12 next year, but we'll see what happens. Okay, that's the Pythagorean theorem. Do we remember this one? It's like, yes, I'm familiar with this. Yeah, here, Nick? Yeah, don't worry about this. If you haven't taken a Math 11 course yet, you haven't seen it yet. You will one day see this. I'm just kind of giving you a bit of a bonus aside. You do not need this until Physics 12, and you'll learn it in the math course before then. Okay, so here's the one that some of you may have seen, some of you have not seen. And Liam, I do remember saying if you are going to take anything other than A and W, you should definitely learn the trig. You opted out. So here are the trig relationships. There are 3 of them, and we abbreviate them using what 9-letter abbreviation? What do we remember? In English. Yeah. SOHCAHTOA. I like to write it like this because it helps us remember how it behaves. Your teacher previously might have just written it like this. SOHCAHTOA. And Lena, you just gave me a weird look. This, I mean, depending on I know it's not necessarily going to translate because the names you give these two sides in German isn't necessarily going to translate. They're not going to start with necessarily an O or an A. So these are English-speaking students. This is how we teach it here, and this is how it works. So when you have an angle, let's use this one as an example. I'm going to label that with that symbol there. That is the symbol theta. That is a Greek letter that we use to represent an unknown angle. There's another one. It's phi, but it doesn't matter. You can also use x, y, or z. It doesn't matter what the variables are. This Greek letter and phi are just often used for angles, and so I'm going to show you them here. So, the way these relationships work is that these sine, cos, and tan, I'll write them out, sine, cos, and tan, are operators on your calculator, because doing this by hand is not super kind. Sine, cosine, and tan. And the way it works is that these three operators will relate an angle that you are working with two other sides. So if you have this angle, we're going to label some sides relative to this angle. These relationships are only true for right angle triangles, so let's put the square symbol down here to represent that that's our right angle. This side across from the right angle is always the hypotenuse. Which is a Greek word, so I'm assuming that it's also used in German.
Yeah, I think it might be one.
Yeah, probably. Hear me. But at the end of the day, that root is Greek, and so whether you're speaking English or French or German, that root should still be there. Well, any of the languages that are based on Greek. But then we use this angle, and we label the other two sides. If you are across the triangle from the angle you're working with, we say that this is the opposite side. And if you are beside the angle that you're working, the angle that you're working with, so if you are this side here, that's not the hypotenuse. This side here is called, in English, we use the word adjacent, A-D-J, adjacent. English word means beside. What do you use in German?
We call like the sides that are on the hypotenuse cathedral, and then we have like the side cathedral and the opposite cathedral.
Oh, so you do use the word opposite. Okay, so opposite leg, and what did you call this one?
Gegencathedral.
Geden. And this one was?
The opposite one.
Oh, so you use the German word for opposite.
Yeah.
Okay. What is the German word for opposite? What's the other one? Because they're not both opposites. Gaden and an? Okay. Okay. So conceptually it's the same, but one was a G and one was an A. So yeah, they're going to be backwards here, but that's okay. I'm willing to bet you've seen it before and can figure it out. And so here's how they work. The sine of some angle theta, and I'll do an example here to show you how this works. Sine of theta is equal to whatever the opposite length is, I'll abbreviate it as OPP, divided by whatever the length of the hypotenuse is, HYP. Cosine of an angle, again this cosine is an operator, is equal to the adjacent side, I'll abbreviate as ADJ, over the hypotenuse. And the tan of some angle theta is equal to the opposite over the adjacent. So this is written like division because it is. It's a fraction, it's division. The only thing that might be new are what the sine, cos, and tan operators actually do and how they work. So I'll show you an example of this down here. I'll move this out so we can see that and we can see the question. Okay, so I've got a triangle there. To solve the triangle means to do what with it? Who remembers? What does it mean to solve a triangle?
To get length of all the sides?
And
The angles.
the measure of all the angles. Find all missing sides and angles. And so let's label them. I'm just going to label them using X, Y, and Z. Let's call that guy X. Let's call that guy Y. And this angle up here we're going to call Z. And so to find these things, we're going to use these relationships here. We're going to use SOHCAHTOA. I'll show you again, I'll review with you or show some of you for the first time how this works. There's one more piece of information that is useful from time to time. What is true about angles in a triangle?
Added up, it's 190 degrees.
Yes. So angles in a triangle add to 180 degrees. That's just always true. So, let's do this. Here's how I would go. Here's one way that you go about solving this particular triangle. I'm going to start with side X. I'm going to solve them in the order that I labeled them in. And so we take a look here. Solving for X, we look at what information we have available. All I've got in this triangle is a 90, which isn't super useful for finding X, a 30-degree angle, and the length of the hypotenuse. So I'm going to label this. This is our hypotenuse, HYP. This is the angle that we're given. And so I'm going to use this angle to label what sides of this triangle are opposite and adjacent. So this guy over here is opposite. It is across the triangle from the angle that we're given. And this guy right here is adjacent. So if I'm solving for X, I've labeled everything in the triangle. X is the adjacent side. I'm given an angle, and I'm looking for the hypotenuse. So which one of these three uses the adjacent and the hypotenuse and an angle? Well, adjacent starts with A. Hypotenuse starts with H. So we're going to use this guy right here. We're going to use the cosine. So the relationship looks like this. Cos theta equals adjacent over hypotenuse. Yeah, you're going to want a calculator handy for this. Ryan, you told me you were going to go to Staples and get a calculator. You had a calculator last year. Where did it go? Did you not? Okay. So this is what we're going to start with, and we're going to fill it in. So we're going to have the cosine of 30. There's nothing to punch into your calculator yet until we've solved this a little bit further, is going to equal the adjacent is what we're looking for. So that's our side X here. So I'm just going to put where adjacent was. I'm going to put the X into my fraction. And the length of the hypotenuse is 12. So cos 30 equals X over 12. Don't punch anything into your calculator yet because you'll get some rounding error that don't want to deal with. We're going to solve this thing for X first. To get X by itself, what do we have to do? Yeah, we have to multiply by 12. So I'm going to multiply both sides by 12. Here they're going to cancel. And I'm going to get 12 times the cosine of 30 equals X. And so we can punch that into our calculator. Exactly as I've written it. 12 times the cosine of 30, close the bracket, hit equals, and you should get, well, these Casios give it to me in the exact form. That's fantastic. But I'm going to write this down as 10.39. I'll take it to two, I'll round it to 2 decimal places. I mean, we could have called that 10.4 just as easily. Are all of you able to get that in your calculators?
Yeah, don't you have like an extra equal sign if you round?
Yeah, it's a squiggly equal sign.
Yeah.
This one.
Can I use that?
Sure. Go for it. I am never going to criticize you for using correct mathematical notation. Yeah. Yeah. Any of you taking a Math 12 course right now? Or IB Year 1? Okay. If you're taking IB Year 1, like right now you have it this semester? Next semester? Okay. Then it's not going to be a problem. If any of you are taking a Math 12 course right now, there is a real possibility that you're not going to be in the right mode on your calculator. There is an alternative mode for measuring angles called radians. That if you're taking, I don't know where in the IB curriculum it shows up, but I do know in the regular Canadian curriculum it doesn't show up till grade 12. So Adafa might be the only one that has to deal with this, and he's not here today. But you want to make sure your calculator is in degrees, not radians. So how I do that on this calculator is that I would go setup, and where it says here on this calculator, it says DEG and rad and grad. I would push 3 to put it into degree mode. And you can see, whatever calculator you have, see if you can see this. Mine's got a D here for a degree. Sometime on this, and it should be on the screen right now, whatever calculator you're using. There should be a little letter D or a DEG. Do you have something like that on the calculator? What kind of calculator do you have? Oh, you have the TI-84? Okay, push mode. And what does it say there? No, the TI-84s should definitely say it. The TI-84s, where's my TI-84? I'll come to you, don't worry about it. Oh yeah, you gotta hit mode. If you hit mode on the TI-84, it's the third, I think it's the third row down. Is it the third row down? Yeah, my TI-84 is broken. Let me come see yours. My screen's toast. Yeah, it is that third row down and you want to shoot your. Mine's toast. Okay, so that's how we'd use that. Now let's find the other two sides, the other side and the missing angle. Now we have all sorts of tools that we can use for this. To find side y, I could use another trig ratio. I could say, okay, well, this is the opposite side. I've got the hypotenuse here. I've got my 30, and I could do it using sine because it is the opposite, and I've got the hypotenuse. Or we could use tan. We could say, well, this is the opposite side, this is the adjacent side, and I could use tan to do it the exact same way. Or I could use the Pythagorean theorem. And the Pythagorean theorem, which you've seen already, looks like a squared plus b squared equals c squared. As soon as you've got a few pieces of information, you can find it all sorts of different ways, which is great. So just get us comfortable using sine, cosine, and tangent. I'm going to use cosine. Sorry, I'm going to use sine. So I have this side, this angle. I'm looking for this side, which is the opposite, and now I've got the hypotenuse. So because I have a hypotenuse, I'm looking for opposite. I'm going to use O over H, which relates to the sine function. So the sine of theta equals O over H, and I want to fill that in. The sine of 30 equals y over 12. I multiply 12 up onto both sides, and I'm going to get y equals 12 times sine 30. We can punch that into our calculator. 12 times the sine of 30 is 6. There's no rounding that needs to happen there. I could have used the Pythagorean theorem for that as well.
When you use opposite over adjacent, it's a slightly smaller number, and I round it up to 6.
Yeah. The reason, so if you use tangent, Vian, and you got what? 5 point?
I got 5.998.
5.998. The reason for that is because, if you recall, this number isn't 10.39 or 10.4. This number is, well, no. This number is actually this as an exact form. Take a look at the screen. Or it's this, But because we rounded it to that, it's going to spit out an answer that isn't exactly this if you use these, you're introducing something called a rounding error, which still rounds to where it's supposed to, you're fine. And I'm willing to bet it was 5.99 and then a value bigger than 5. So even if you rounded it to 2 decimal places, you still would have got 6.00.
Yeah, I got 5.9.
998, yeah. So the rounding error is small, but it's still there. And then the last one, to use trig to find an angle, let's find Z. And the beauty of using, or the last thing to find, there's always so many options. I want to find this angle. There's a few ways you could do it. We can use any of sine, cos, or tan, because we've got all of the sides. If I'm looking at this angle now, how we label opposite and adjacent is going to change because I'm changing the angle. If Z is the angle that we're looking at, then this side becomes the opposite, and this side becomes the adjacent. The hypotenuse stays the same. We could also use that angles in a triangle add up to 180 degrees, but because I want to introduce or review the inverse angle, the inverse operations, I'm going to do this way. So to find Z, I'm going to relabel these. X is now the opposite, Y is now the adjacent, and this is still the hypotenuse. So I'm going to use the hypotenuse and the opposite because we have exact values for these. This one's, sorry, the hypotenuse and the adjacent to Z, because we know this is exactly 6, this is exactly 12. And so that's the one I'm going to use. And I'm going to say, okay, the cosine, do I want cosine? I do want cosine. The cosine of an angle is equal to the adjacent side over the hypotenuse. The adjacent side to Z is now this side over here, Y. So I'm going to get the cosine of Z. I'm going to zoom this in over here so you can see it. The cosine of Z equals the adjacent side, which we know is 6 long, divided by the hypotenuse, which we know is 12 long. And just like every other mathematical operator you guys have ever played with in math, there's an opposite operation to this. The opposite operation for cosine is it's got a few names. Cosine to the power of negative 1. So students will always say cos minus 1. That to the power of negative 1 means inverse. So sometimes we call this thing the cos inverse. Proper mathematical language calls it arc cos. And then I don't know what you're doing in German. But either way, we want to use the opposite operation to cosine. So I'm going to use the inverse operation. So Z then is going to equal the cos inverse of 6 over 12. And then to punch that into your calculator, you would push the second function or the shift function and then push cos. It'll, on the Casios, it'll go cos inverse. It'll open up a set of brackets. We're going to go 6 divided by 12. We're going to close the bracket. And it's going to tell us that that angle Z is 60 degrees. Which is great, because that's what we expected it to be. Because if the angles of a triangle are 180, one of them was 30, the other one was 90.
I feel like you could have just taken 2 values and found
You could have.
the last one.
I know, but I wanted to, especially you, Liam, who's never seen this, I wanted to make sure you saw it. Yeah, we could have just said, oh, angles in a triangle are 180, one of them's 90, one of them's 30, there's my 60. I found it 2 different ways, that's fine. So there's my crash course on reviewing trig. It's not difficult, it's just different, perhaps, than some of the stuff you've seen before. And so I'm going to give you some time to play with these guys now, just to make sure we're all good with the trig. There's a bunch of word problems here, and if you want more practice, I can provide you with more. But taking a look here, this one talks about angle of elevation and angle of depression. What this language here means, elevation is up, depression is down. So what how this looks is if I have an angle of elevation, that's the angle I'm talking about. If I have an angle of depression, that is the angle I'm talking about. So each one of these questions is going to require that you draw a triangle, fill in the sides, and come up with some values. Okay? I'm going to give you some time to play with this stuff, just to make sure we're all on the same page with the trigonometry. To make your life easier, please do not write on this page. Either grab some of your own paper, your line paper, your graph paper that I gave you, or I have 7 whiteboards in here. You guys are welcome to use them. The whiteboard pens are on the front. Feel free to move to the whiteboards, get up, move around. You've got lots of space. Actually, you know what the hilarious part is? I've divided all my whiteboards into 2, so I have 14 sections of whiteboard, and there's 14 of you. I could give each one of you a half a whiteboard. That's awesome. On your mark, get set, give her, and I'll move around and help as needed.
The last